Write the left and right Riemann sums in sigma notation for n equals 20, 50, and 100. Evaluate with a calculator. Okay, so we have the integral here from 0 to 1 of x squared plus 4 dx. Okay, and we're asked to write the left and right Riemann sums. Now those are a lot of subintervals, so I'm going to show you how to do this in the calculator. But first we need to come up with the formula for this. Okay, so the Riemann sum formula is k equals 1 to n, the sum of f of x sub k times delta x. Okay, now our function here is f of x is equal to x squared plus 4. And for our first one, we have n equals 20. Okay, so let's start by writing our left Riemann sum. Okay, so remember that the left Riemann sum is starting from the leftmost part of your interval. Okay, and that's important on how we write this Riemann sum. So we're going to go from k equals 1, and for our first one we'll go to 20. That number will get changed to 50 and 100 as we do more subintervals. Okay, and we have f of k minus 1 divided by 20 times 1 over 20. Now, where's the 20 coming from? Okay, well, we have n equals 20 subintervals, and we have the interval from 0 to 1. Okay, so the number that we're dividing here is 1 minus 0 over 20, or 1 over 20. So that is our delta x. And it's also the number that we're going to divide inside the function, because that's where we're evaluating the function. If we have 1 over 20 as our subinterval, then since we're starting with a left Riemann sum, we want it to start at 0, because that's the beginning of our interval. Our next one's going to be 1 over 20, 2 over 20. I could reduce that, but I'm not going to. 3 over 20, and so on and so forth, all the way into 19 over 20, and that's going to be our last subinterval. So we have to write this in such a way that this becomes these intervals. Okay, so we have our delta x here, but the 20 here is coming from these subintervals. So watch when I plug this into the function. K equals 1 to 20. Okay, so I'll plug this in, and remember it's x squared plus 4 is our function. So this, it only goes in place of the x. So it will be k minus 1 squared over 20. Well, the 20 is going to get squared too. So k minus 1 over 20 squared. And then times, or plus 4, and then times 1 over 20. Okay, so let's see if this actually worked out. Okay, so if we plug in a k equals 1, plug in a k equals 1 here, that would be 1 minus 1, which would be 0. So our first one is going to be 0. That's what we wanted our first one to be, right? Okay, so 0 squared plus 4. So that works. 0 squared plus 4. Okay, if we plug in a k equals 2, 2 minus 1 is 1. So we get 1 over 20 squared. This is our second one that we want, right? 1 over 20. So if we plug a 1 over 20 into our function, we would get 1 over 20 squared plus 4. And plugging in a 2 here gives us 1 over 20 squared plus 4. Let's try one more. We plug in a 3 here. Hopefully we get 2 over 20. Okay, so we plug in a 3 here. We get 3 minus 1, which is 2 over 20. So 2 over 20 squared plus 4. Okay, so this works for the left Riemann sum. Okay, so I'm not going to put it in my calculator yet. We're going to save that for the end. But this is our left Riemann sum for 20. You can extrapolate for n equals 50 and 100. You would just change the 20, all these 20s to 50s. Okay, so I'll write one of them. K equals 1 to 50 of k minus 1 over 50 squared plus 4 times 1 over 50. Okay, so that's for n equals 50, and of course the 100 would be the same. Okay, with 100 in here. All right, let's do the right one before we go into our calculator. So the right Riemann sum. The only difference between the right Riemann sum and the left Riemann sum, the left starts at 0. Well, it doesn't start at 0 necessarily, but on this interval it is going to start at 0. Okay, it starts at the beginning of your interval, at the leftmost of your interval. So if you have the interval between 0 and 1, say this is 0 and this is 1, and you have all the subintervals, you have 20 subintervals, you're starting here. You're going from here to here and here to here, okay, this way. Okay, the right, the difference between that and the right, you have this same interval here from 0 to 1, except you're going to start at 1 and go backwards on your rectangles that you're drawing. Okay, so our first one that we're plugging in is not 0 like it is on the left. It's 1 over 20 is going to be our first one. Okay, so we have to slightly change this formula here to recognize that we're not starting at 0. We don't want our first one to start at 0. So we no longer need the k minus 1. The k minus 1 was there so that when we plugged in 1, we got a 0. But we don't need a 0 anymore. We need a 1 on top. Okay, so we no longer need the k minus 1. We just need the k. So we have k equals 1 to 20 of k over 20 squared plus 4. And that's still multiplied by 1 over 20, which is our delta x. Let's make sure that works, because we should be getting 1 over 20, 2 over 20, 3 over 20, all the way over to 20 over 20, which is 1. Okay, so let's see what happens when I plug in a 1 here. 1 over 20 squared plus 4. That's exactly what we should get, because when we plug in a 1 over 20 here, it's 1 over 20 squared plus 4. Okay, plug in a 2, you get 2 over 20, a 3, you get 3 over 20. Okay, so that, just like the left one, if we wanted to make it 50, we would plug in a 50, 50, 50, and that would be the formula. And for 100, plug in 100, 100, 100, and that would be your formula. Okay, so those are the formulas for the left and the right Riemann sums for all those subintervals. Now let's go to the calculator. Now I have a TI-84 Plus, and I've upgraded my operating system so that I can write in summations. If you haven't upgraded the operating system, I'd suggest that you go upgrade it. It's a free upgrade. You just need a USB cable. I think it's a micro USB or a mini USB cable. Maybe you can see the outlet on top. It goes in right here to your computer, and it's a free download. You just go to Google and search for the download. Okay, so given that, we can hit math and go down to where it says summation, and it pops up and allows me to type in this stuff. So I'm going to use x instead of k. You can use k, but I get tired of hitting the alpha button every time I want to type in an x or a variable, so I just use x instead of k. It'll give me the same result. So x, and I start at 1, and I go to 20, and I'm doing this first one right there, right where my calculator's under. Okay, so 1 to 20. Open your parentheses, open the parentheses again. Okay, notice how many parentheses we have. The whole summation has one parentheses. Then we have another parentheses around this part, and then we have another parentheses around this part. Okay, so make sure you have 3 parentheses with the fraction as well. So we have x minus 1, close parentheses, divide by 20. Okay, so that takes care of that, making sure that the x minus 1 gets divided by 20. Close parentheses around that and square it. It's very important that you type this in correctly, because you can't get a wrong answer if you don't use the correct number of parentheses. Okay, then add a plus 4 and close parentheses. And then open parentheses and times it by 1 over 20 and close parentheses. Okay, so let me go back and show you what I've typed in here really quick. Okay, so we have a total of 3 parentheses. There's the x minus 1, close parentheses around the top of the fraction. Divide by 20, close parentheses around the entire fraction. Square it, plus 4, and then close parentheses around the entire sum. And then multiply it by 1 over 20. Okay, and then hit enter. And you get your answer with 20 subintervals Okay, so I'll put that, let's put that right here. 20 subintervals gives you 4.30875. Okay, I can hit second enter if I want to just change the numbers like I do. Change that to a 50, change that to a 50, and the top number to a 50, and hit enter. Okay, so 50 subintervals gives me 4.3234. And finally, 100 subintervals. You might have to use the insert button. So second insert 1, and that's enough, just so you can have enough digits without messing up the entire thing. So second insert, put a 1. You don't need to keep inserting, just insert one digit and then kind of move your cursor around there and then just type in 100. And then on top, whoops, on top, you can just type in 100 there. Okay, took it a minute because it's a lot of subintervals. Your calculator is actually crunching those one at a time. So for n equals 100 for a left Riemann sum, we get 4.32835. Okay, so you can see that they're all pretty close. Okay, and we seem to be getting closer. The more subintervals, the more accurate you are. Okay, now let's do the right Riemann sum. So it's a slightly different thing, so I'll go through this again. Math, go down to summation. X, 1, 20 on top. Okay, so let's go through this again. It is going to be x over 20, quantity squared, so open parentheses. We need less parentheses this time, although it won't hurt if you leave these parentheses here where the x minus 1 was when there's no 1 or no minus 1. You can still leave that parentheses there. It's not going to hurt anything, but you don't necessarily need it. So x divided by 20, close parentheses around x divided by 20 and square it. Then add 4. And then close your parentheses, or just move over, and multiply that by parentheses 1 over 20. Okay, so for a right Riemann sum with n equals 20, we get 4.35875. Okay, so not exactly what we got when we did the left Riemann sum, but close. Okay, you can see the difference, 4.30875, 4.35875. Okay, let's go do that really quick with 50. So for n equals 50, we have 4.3434. And finally with 100, and this will probably take a second for the calculator to, no, pretty fast. All right, so n equals 100 gives us our answer of 4.33835. Okay, so we could do that with even more subintervals. The calculator will take longer and longer to do it, but this is a pretty good approximation. So what we're saying is that given all these approximations, the more the better. Okay, these two with 100 are going to give you your best ones, and you could even average those two to get possibly a better one. So I can do that really quick. So let's do 32835 plus the answer that we just got for the other one, divide by 2, and it gives us about as good of an answer as we can get using Riemann sums. And it's saying that this integral, if we were to evaluate it, would give us about 4.33 as an answer. Okay, now you can evaluate this integral, and if you don't know how to do it yet, you will soon, and you'll be able to compare the answer to this to the actual answer of the integral when you plug the limits in. And that's it.